Hello guys, welcome everyone. I hope you have having a good time. So this is Nitin from Bhaskara section from the Department of Computer Science and Engineering. So today's my topic is about cryptography. The elliptic curve cryptography is the topic headline. So let's get started. Elliptic curve cryptography. So elliptic curve cryptography is a powerful technique that offers secure data encryption and authentication. Learning about the history of cryptography and why the elliptic curve cryptography is the future. So first we learn about the history of this what ECC. So the history of elliptic curve cryptography says elliptic curve cryptography was first proposed in the mid 1980s as an alternative to traditional public key systems. It gained popularity due to its efficiency and strong security properties. So it has gained popularity among the users by its strong security properties. So the ECC has since become a cornerstone of modern encryption algorithms used in a wide range of applications, and from secure communication protocols to digital signatures. So from there on, it has been widely used in every applications. So that has been taken on in the real world applications. So moving on to the next, so we have the introduction to the elliptic curves. So what are basically the elliptic curves? The elliptic curves are nothing, they are a type of an algebraic equation that describes a curve in a 2D plane. So they are widely used in cryptography due to their mathematical properties. So the elliptic curve is just algebraic equation that describes a curve in a 2D plane. So why are they important? So the elliptic curve provides a foundation for modern cryptography and offer an efficient way to secure data in variety of applications. So they are important because they provides a foundation for modern cryptography and provides a efficient way to secure data in a variety of applications. So how do they work? So ECC, elliptical cryptography, curve cryptography uses the properties of elliptical curves to create secret keys that are used for encryption and decryption. So in this technology, they use one called secret keys, where these are the main things. Each is used for encryption and decryption. They provide a higher level of security than the traditional encryption techniques. So this use of secret keys will provide a higher level of encryption than compared to traditional encryption technique. So by considering an example, imagine there are two people standing on a curb, so they can easily communicate with each other without anyone else listening to them. So basically, there are two people there standing in the path of a curve where they can easily communicate with each other without actually the others listening to them, or without actually the others getting the data from them. So this is the working principle behind elliptical curves. So the elliptical curve cryptography basics. So the basic fundamentals of this cryptography is a key generation. A private key is generated by randomly selecting a point on the curve and then adding the point itself for a certain number of times. So this encryption works as there's a private key that is being generated by randomly selecting a point on the curve, then adding that point itself for a certain number of times. So this is encryption and basically the key generation. So encryption will be carried on after the key generation, and the sender uses the receiver's public key to encrypt the message and creating a secret that only the receiver can access using their private key. So the sender that uses the receiver's public key to encrypt the message and creating a secret message will send to the user or receiver, who can access this message by using a private key itself. So the decryption, to decrypt the message, the receiver you need to use the private key to compute the shared secret. So there will be a public key as well as a private key. The private key is being given to the receiver who need to access it and use it to access the message that has to be being decrypted. So this is decryption, and we have the authentication. ECC is also used for digital signatures which provide identity verification and non-repudiation. So ECC is also used in the digital signatures. So nowadays the digital signatures has been in talk for while, and this digital signatures use identity verification also. So this has been provided by elliptical curve cryptography. So moving on to the next. So we have the security advantages of ECC over the other systems. So there are some advantages of ECC over the other systems, because if a system is efficient, it should be having advantages over the other system which are inefficient. So the first advantage is the faster processing time. So ECC requires smaller key sizes than the other systems, and which makes it faster and more efficient. So key size is very small. And better security. ECC offers a greater security with smaller key sizes. So this means that the system is more resistant to brute force attacks and other forms of attacks. So it uses smaller key sizes, so it is more resistant to brute force attacks. So the brute force is basically the cracking of the keys. So it is one of the methodology that is used to crack the keys. So it is not that easy to crack this key, what is being generated by ECC. So there is a lower bandwidth. So ECC requires fewer resources than the other systems, which makes it good choice for a low power devices and high security application. So as a system, ECC requires a low power devices, and which makes it a good choice for the users all over the world to have it as a choice of security systems. So this is what the security advantages of the ECC over other systems is. So now will be talking about the applications of ECC. So the applications is smart cards, mobile devices, Internet of Things, and virtual private networks. So the smart cards that uses ECC to secure these transactions and other sensitive information. They are commonly used in banking and financial industries. So the smart cards have been used by the customers for their cash transactions. We'll use ECC as a security method. So then we have the mobile devices. So ECC is used to secure data on mobile devices and provides secure access to data in the applications. So then we have the Internet of Things, where ECC provides secure communication and authentication for Internet of Things devices and networks. So then we have the VPNs, that is virtual private networks. So ECC is used to secure VPN tunnels and ensure privacy and security for sensitive communication of the data. So these are the applications of the ECC that have been seen in the real world. So then we have challenges in implementing the ECC. So there will be some challenges for implementing a system. So the key size. The ECC requires a larger key size than the other systems to offer the same level of security, and the patent issues, much of the software and technology related is patented, so which make it difficult for the developers to use it. So this is another challenge. And the last one is the standards. There are no universally accepted as standards for ECC, so which can lead to interoperability issues. So if there's no standard for any system, so it would be a chaos. So this will be one of the challenges in implementing ECC. Now, lastly, I would like to talk about future aspects or prospects of ECC. So, where the future prospects of ECC is the quantum computing resistance. So, the ECC is resistant to quantum computing attacks, for making sure an ideal solution for the future proofing of data security. And the higher security, the potential for more secure data transmission and storage is driving the adoption of ECC in new and emerging technologies. So this is also a future prospect of ECC. And ease of use. So ECC is becoming more accessible and easier to use thanks to development of new implementation and standards. So this all prospects will be the main points for the futuristic use of this ECC. So this is all about elliptical cryptography, commonly called as ECC. So I would like to thank you for spending your valuable time on my slides. So this is Nathan and I'm signing off. Have a great day.